Hello, this is Dr. Hassan Abdullah with the course Deep Reinforcement Learning. And the topic which we are covering is reinforcement learning. And this is the 10th topic in the list of topics which are covered in this course. And the subtopic is B. So the lecture is 10B. So the difficulty of this video lecture is from easy to moderate. And this video lecture is prepared using the supplemental website accessible at www.ezmcq.com/goget, which is a personalized learning management system. So, what is the future of content delivery? So, the future of content delivery is delivering the content online, and the wonderful features and the benefits are in front of you. And this approach is used by hundreds and tens of millions of users worldwide, which use content delivery for the learning purposes, for education purposes. And we are going to be following the same approach in this course also. So, in green color is the URL for the personalized learning management system, and in blue color are the videos which explain the features of the personalized learning management system with reference to the future of content delivery, which is, as a matter of fact, the present. So, what it supports is advanced and basic text search in the content of the course coverage, which is not there in very popular learning management systems. And then, of course, if there are any students with visual disabilities, they can also change the font, the color, the line spacing, etc., to suit them to their requirements, which is also not there in leading learning management systems. And then all the content is kind of opens up and unrolls so as to optimize the small screen of a handheld smart device. And you can also track your progress, what you have covered, what you have to cover. And of course, you can also test yourself online in real time about the knowledge assimilation and the knowledge which you have acquired, and the weaknesses are also identified. So, what is the approach of content delivery? So, there are two approaches. One is the question and answer based, which is proactive, which is engaging, and which is also promotes thinking also. And the other approach is the traditional approach in which a lot of details are provided. So, the approach we have adopted is a blend of both approaches, that is Q&A and traditional learning also. So this is the list of topics which are covered in this course, and we are at topic number 10, which is reinforcement learning. So this is the breakdown of the list of subtopics or the concepts which are covered in this video or in this sets or series of videos. So 10A in yellow color are the basic or the fundamental concepts of reinforcement learning. And as we proceed from A to B and so on up to E, the difficulty increases progressively. And for the video lecture 10E, we have the more challenging concepts. And now we move on to the details of the video. So we are at 10B, deep learning, and it's reinforcement learning. So what is meant by solving the maze problem? So what is the maze problem? And for this case, we consider the rat and cheese scenario. And of course, there is an animation also. So let's look at the answer. So first let's look at the animation. So as you can see that there is a maze and there are obstructions in the maze, and those obstructions are shown by red boxes, and the rat moves in that maze, avoids those red boxes, and reaches the cheese. So that is the rat and cheese maze problem. Now how it actually happens, how it's implemented, so what's going on. So first of all, let's look at the what that problem really is. So in reinforcement learning, that is the classical rat and cheese scenario, which is using the Markov decision process. And I've explained the goal to you. So what is the objective is to reach the cheese while minimizing wasted moves and avoiding the penalties. That is the objective, because then it's optimization. So then there's a state which represents the maze positions. I'll go into the detail state, and of course, then there are actions. Actions are moving in a certain direction, up, down, etc. And then there are the rewards, which encode the desired behavior. So positive for the goal, negative for each step or illegal move, and the agent learns a policy mapping, right? So over the period of time, it solves the maze when its policy reliably guides it along efficient paths, not inefficient paths. So let's look at the details which we'll be looking at are as follows. So what is meant by objective? So objective, as I have just mentioned, is to reach the target cheese from a starting point, and that should be optimally in terms of length of the path or the cost, avoiding the obstacles and the unnecessary moves. Now the reinforcement learning setup transform this into maximizing cumulative reward. Remember that in reinforcement learning, it's always the delayed reward, unlike game playing where you score a goal and you have an instant reward. So the ultimate reward is given at reaching the goal, and the interim penalties guide the efficient behavior. So then is the state. So state in that maze uh, typically encodes the agent's current position in the grid and the optionally local environment, such as the walls, such as the visited cells. So this state representation is what the agent sees, and based upon these states, the agent takes the actions. So what are the actions? Are the possible moves the agent can take in a state? So usually there are four directions: up, down, left, and right. Now some formulations of the state allow stay, or they also penalize illegal moves like uh, trying to go through a wall. So these actions and transitions that take the agent to a new state, okay, which then ultimately yields a reward. Okay, so what is the reward here? So rewards define the feedback to the agent. Now reaching the goal gives a strong positive reward. Now each step often gives a small negative cost. Why? To encourage the agent to take shorter paths and to avoid illegal paths or to avoid revisited moves. They are going to result in penalties. Okay. So ultimately, the reward structure is the central to shaping the learning policy. So what is the policy? Policy is a mapping from states to actions that can be deterministic if it's rule based, or it can be probabilistic also that the agent follows. Now the goal of reinforcement learning is to learn a policy for any maze state, and that yields the corresponding action to lead towards the goal where the award is expected and its maximum award. Over a period of time, the policy refines and the optimal path is also approximated. What you were shown was the after the end of all the things which had happened, that the learning had taken place. So the learning process, the learning process involves repeated episodes, and the agent interacts with the maze, observes the states, takes actions, receives rewards, gets penalties, transitions to new states, update its value or policy parameters. So over many iterations, this policy improves. So what you are seeing is the consequence of the improved policy. So what is meant by solving the problem? It means solving the maze means the agent's policy reliably guides it from many starting positions, that is many starting positions, okay, to the goal with minimal cost by avoiding the traps. Traps are not shown here, avoiding the loops and suboptimal detours. So a solved reinforcement learning maze uh, setup often yields high success rate and near optimal paths, what you were seeing. So the learned solution should generalize, or and it should like adapt to slight changes in the maze also. All right. So this is what it is, and here are the details. You should read these details, and here are the references. Okay. So provide definition, goals, an example of supervised learning, unsupervised learning, transduction, and reinforcement learning. Now, these four paradigms, let me show you. So, we're looking at these four paradigms here, okay? So we have machine learning, we have supervised learning, we have unsupervised learning, and we have reinforcement learning. Okay. So transductive learning, we are not spending a lot of time on it. Okay. So supervised learning is further divided into classification and regression. So classification. So these four learning techniques are distinct modes. Okay. So we have covered supervised learning and we have covered unsupervised learning also. So transductive learning bridges the two types of these learnings, okay, by making predictions only on a given unlabeled data set. So it leverages both labeled and unlabeled data without generalizing broadly. Now, reinforcement learning is fundamentally different. The agent learns through trial and error. It's very different. Agent learns through trial and error. Okay. So there's an action and then there's feedback. And while interacting with an environment and receiving delayed rewards, the objective is to optimize a policy. Now, in the context of deep reinforcement learning, supervised and unsupervised methods often complement reinforcement learning by providing better feature representations, or they kind of imitate learning. But reinforcement learning, remember, remains the paradigm for learning decision making behavior in dynamic settings. So, reinforcement learning is quite different. So, we have covered supervised and unsupervised learning. Okay. So, spending slightly more time on transductive learning. So, basically, it focuses on predicting specific test instances without creating a general model for all possible inputs. So, it uses both training and test data during learning, and while optimizing performance on a given test set. Now, this approach is common in semi-supervised learning and the classical classification, especially when there is scarcity of labeled data, when there is limited labeled data. So, reinforcement learning. So, reinforcement learning uh, involves an agent who learns by interacting with environment, receiving rewards or penalties. What is the objective? Is to maximize the cumulative reward over time. So, where it is used in areas like robotics, like game playing, certain type of games, autonomous systems, and what they have in common is sequential decision making and long-term planning. All right. So that's the areas where it shines most. So what I just discussed is given here. Okay. Please read this, and there are the examples also given here, like canonical example of. Okay, let's move on. So what is next? Now, how reinforcement learning is different from supervised learning. Give examples. So how they are different. Now, this is the classical quote from Napoleon Bonaparte. So you must not fight too often with one enemy. You fight with your enemy, but not too often. Else, you will teach the enemy your art of war. So the enemy will learn how you fight. That's a classical example of reinforcement learning. And let's look at this example here also. So how reinforcement learning works. So we have this agent here, and there is fire, and there is a bucket of water also. So the agent observes this is fire, and this is bucket of water. So the agent selects an action, takes the action, and burns. So minus 50 points action. So get a reward or penalty. So that is bad. So next time avoid the fire. So update the policy. That is a learning step. And iterate until an optimal policy is found. So maybe next time the agent doesn't get comes across fire, but comes across coals. The coals don't have a flame, right? But they still burn. So the policy is updated. So if something is glowing can burn. So next time maybe the agent comes across a hot rod or something, which is neither burning nor glowing, but it's still hot. So it kind of optimizes the policy. Okay. So until it is sufficient to go through all the environment, right? Okay. So Now, reinforcement learning differs fundamentally from supervised learning, okay? Because the learning dynamics are different, data acquisition is different, objectives feedback is different, and then the necessity of exploration. Now, on the other hand, supervised learning is kind of passive. It learns from a fixed data set, from a labeled data set, and there is immediate feedback, okay? But in reinforcement learning, there is an active interaction with an environment, okay? And then that interaction generates sequential experiences, and the agent is seeking to maximize the long term reward. So the learning process in remote learning is intertwined with the environment. As a matter of fact, it interacts with the environment. So there is no pre-given data, but that data or the experiences are collected over by the interaction. So the objectives are long term. So the objectives are strategic, and the feedback is delayed, right? And it is kind of scalar. And there is a balancing between exploration and exploitation, which is essential. But these differences make reinforcement learning more challenging, okay? But at the same time, it is more powerful, not in all the domains, but in certain domains, such as decision making, such as control and sequential interaction, especially when it is combined with deep, deep reinforcement learning. So, what is the learning process? So, what is the learning process? So, supervised learning is static. The model learns from fixed examples and without influencing the data. On the other hand, in reinforcement learning, the learning process is interactive. The agent takes actions, the agent receives feedback, and the agent determines which data it sees next. So, this is a closed loop process. What it means that remote and reinforcement learning must consider how exploration influences learning or how learning influences exploration. Okay, so there's a big difference here. Then are the data requirements. Supervised learning consumes labeled input output pairs, supervised learning, and typically it assumes some identifications also. However, in reinforcement learning, it generates its own data. How? By interaction, where interaction with the environment, and it deals with sequential data and sequential experiences. And it is proactive. The agent must actively explore the environment to collect informative data for learning. So it is very different from supervised learning. Now, what is the objective? In supervised learning, the objective is to minimize the prediction error, okay, based upon the examples. Now, in reinforcement learning, the objective is more complex. What is the objective? Is to maximize the cumulative rewards across time and considering future consequences of the actions. So there is kind of a there is strategy involved. So now this policy is optimized over trajectories rather than isolated instances, okay, which is the case of supervised learning. Feedback mechanism. Supervised learning gets uh, immediate feedback like based on the errors. So there's dense supervision for every example. Now, reinforcement learning receives only scalar reward signals. Kind of, they're not kind of comprehensive. And they can be sparse and they can be delayed. And that creates kind of a credit assignment problem. What is meant by credit assignment? Because the rewards are attributed to the actions that were taken earlier in a trajectory. So the concept is very different as compared to supervised learning. Now, as always, exploration versus exploitation. In reinforcement learning, the agent must actively explore to discover new actions and then exploit known ones to acquire the reward. Now, this trade off has no counterpart in supervised learning. Balancing exploration and exploitation is essential for efficient and robust reinforcement learning. Okay.